Agenda of today's lecture is fine-tuning. What are the different types of fine-tuning? How do we implement fine-tuning? And apart from that, we'll take agentic AI with some of the questions, right? So as we can understand that fine-tuning is done on the large language model. So this is fine-tuning large language model. So first of all, we have to have a LLM, that is on large corpus of the data, right? So the next task is fine-tuning the model on a specific task. So the LLM may be on generic data, but we can make it for the specific task data set, and it is ready to be used for real world application on that specific task. For example, we want to do it for sentiment analysis. So there may be a lot of or huge data, but we want to have only the specific data. So again, we have to train the same model on our classified data. Yes. So what is this fine-tuning in NLP model is the process of adapting a pre-trained model to perform a specific task by training it again. That is a question. So do we need to train it again? Yes, because it is a huge data set, and we have to take the specific thing. So model is same, model will remain same. All the parameters will remain the same, but we'll train it again on a smaller or a task specific data set. So if we have the general LLM, we can make it specific for our use. So that is the beauty of fine tuning. So if anything is readily available to us, we can use it and can tune it according to our need. So we should have the data set. If it is a supervised learning, so we should have a labeled data. So pre-trained models like BERT, GPT, Roberta are first trained on vast amount of general text data to learn language, patterns, grammar, and context. So you know very well that BERT, GPT, and Roberta, these are some good trained models on generic data set. So we can make it specific, having some efforts. We can put some efforts and make it specific for our data sets. So let's take these three one by one with the simple examples. So as the name says, B stands for bidirectional encoder representation from transformers. So transformer has got two parts basically, encoder and decoder. If we use only encoder, then it is, the example of that is a BERT. And what is bidirectional? It if we talk about a word, so we before word what has been said and after word what has been said in terms of words again, then it is a bidirectional. It means it goes in left and right both sides. It is developed by Google, model designed to understand the context of the words in a sentence by looking at both the left and right surroundings. So now the question is how much we can go in right and how much we can go in right. So that depends on the context window. If we say we have a word W, 0, so it would be W minus 1, W minus 2 if window size is 2. Similarly, W plus 1 and W plus 2, right? If WI is the correct word, then it may go maybe 3 words, 4 words, 5 words, or 16 words. That again depends on the model. So unlike generative models, BERT is an encoder only model, while GPT is a decoder only model. It is trained on the masked language model. What we mean by mask? Mask is something kind of hidden. We hide the words and they predict the words using the model. So kind of a Y. Y is equal to F of X. X is your input, F is your model, and Y is label. So why is a hidden word? It is already there in the training dataset, but we hide it for predicting it correctly. What is going in the flow in the training dataset, and if we are able to predict the same word, it means our model is accurate. So why do we do it? To create deep contextual representations for understanding the task. So in NLP, there's always challenge with the context understanding, right? So the same example I keep on taking is a, say, bank. Bank is a financial institution or is the edge of the river. So the context are two. We have a virus. Virus is in a biological virus or a computer virus. If I say Python, Python is the name of the snake or a programming language. These are the different contexts. So the question is, we want to understand the context. These are the simple examples. There may be a complicated context also. So it's not about the 2 words behind or after, before and after. It may be 20 words before and after, right? That is what we learn it from the deep learning. So that is what BERT is doing for us. So the same example, the bank is on the river. The bank is on the river. So which bank we are talking about? What is our concept? So the bank, here the BERT looks at the and is in between the bank. After the bank is and before the bank is the. So BERT looks at the and is, the left context and right context. And on the and river. River is a right context. So it understands that we are talking about which context. So bank is a financial institution, right? As it sees river in the same sentence, it understands the context is geographical, not financial, right? So of course the bank may be at the river, but here the BERT will understand the context of geographical, not financial, because river and bank both are coming in the same sentence. So that's why we want to make it perfect, that it should take it correct. So instead of taking it, it may create ambiguity. We are talking about the financial bank. So something has been said after the sentence and before the sentence so that we can reach to the correct concept or context of the word. So here the bank word is in question, which bank we are talking about, right? So this is what BERT is helping us. Another example of the BERT is disambiguating. Disambiguation is if there is an ambiguity, we need to overcome the ambiguity. We need to remove the ambiguity. That is known as a disambiguity. So words say Python. In the sentence, he got bit by a python. And Python is my favorite programming language. So because we are the intelligent person, human beings are the intelligent person, they understand that whenever the bit and Python is there, it means we are talking about the snake. And in the second sentence, Python is my favorite programming language. It's obvious that here we are talking about the Python, which is the name of a programming language, right? So here we need to disambiguate. So BERT does it for us. So these are the 3, 4, 5 examples I can put it here. They may be 5,000, 6,000 or 6 million. So everything is well understood by the BERT depending on the context. And these contexts, it keeps on changing. This is known as a dynamic contextual embedding. So as the BERT understands that the word Python refers to the snake in the first sentence and coding language in the second. Is true? You can say something in the chat so that I understand that you're getting it. I request everyone to please write something in the chat so that I can see that you are getting. Anyone can write in the chat? Are you there, participants? Okay. So I am assuming that you are getting it. So context-free models, like question is, are you getting my voice? Are you getting my screen visible? Are you getting my context, what I am making you understand? That is what I ask you to write something. Yes. So yes. Okay. So we have context-free models that we already covered. The like word to vec that would assign the same vector to Python in both the cases. That is a static embedding. So in both the sentences, Python is a common word and it will have the same embedding, while the Python context is different in both the sentences. First one is related with bit or byte, and second is programming language. So aiding in improved search accuracy or categorization, the word embedding must be context aware. What if they have the different embeddings depending on the context, so that it is easily understood that in which context it has been talked about. The third example is the animal didn't cross the street. We have taken the same example before also, because it was too tired. What is it? Bird uses bidirectional attention to determine it refers to the animal, because animal was too tired. Animal didn't cross the street because it was too tired. So uses bidirectional attention to find who was tired. Who was tired? It was animal only. So it is how it is resolved in BERT. So there's one more term that is known as a masked language modeling. The same example I took in my second class. The cat sat on the mat, right? For example, it is a answer is mat, but it has been masked. Masking is hidden. So BERT uses the surrounding context to predict what is there. How does it happen? Unlike the other models, it takes only left to right. BERT analyzes the entire sentence at once. Allowing to understand that set on the strongly suggested surface, that is a mat, or maybe chair, or couch, or sofa, or rug. So how many times it happened in the generic data set? So the cat sat on the mat, say 500 times it came. Chair it came only once. Rug it came 550 times. So it will take only the cat sat on the mat because it is frequently occurring. So that is what it is guessing. Mask words in the massive data sets. The next is GPT. First we have done the BERT. Now second is GPT. GPT is a generative pre-trained transformer, a family of AI models developed by OpenAI. The BERT was developed by Google. It is developed by OpenAI, and that can understand, generate, and process human-like text. So question is, here we need to generate something. First, it is to be understood, then generate, and it should work like a human-like. It's not kind of a robot kind of speech. It should be written like a human. So these models use a transformer architecture. BERT also used transformer. GPT also used transformer to process language by examining the relationship between words in a sentence simultaneously. So generative, it means it creates new, as the name says, generative. It creates new. There are three parts of this GPT. First is generative. It creates new. Pre-trained, it means we are using it, the model which has been trained already on a massive data set, used data set. The third one is a transformer. So a neural network architecture that excels at understanding context and relationship between words. That is how the new things to be generated. If I say the cat sat on the mat, mat comes from neural network architecture, right? And they are far apart in a sentence. They are not very near to each other. So if we take the same words, those are already there, that is not a generative thing. It is only predicting thing. So here in the GPT, something that is similar has got the same context and having the relationship, then only we take that word. They may be far apart in a sentence, but somehow they are having the same context and similar related meaning. So let's take an example of GPT. One is content generation or content generation. So content generation, we can write something, we can write a story, we can write an email, we can write a poem. But the thing is, it must be creative. It is not kind of a monotonous. That is the newness. So GPT can generate blogs, posts, articles, emails, stories, poems, and many other things. Even the images can be created. It understands tone and style, which is needed to adapt to specific users' needs. So now the question is, how do we find the user's need? That is through the prompts. So if we have the clear-cut prompt, what exactly is needed, that prompt is again in the NLP, natural language, not NLP, it's a natural language. So natural language is nothing but the collection of words, and every word has its own embedding. So the prompt's embedding will be included into the words. Those are part of the training dataset. Let's take an example. A marketer prompts GPT with write a 100-word product description for a new eco-friendly water bottle. This prompt is very clear. It says we need 100-word description about the product, and the product name is new eco-friendly water bottle. So many things have been included, and every word here will have a embedding, and that embedding will be the part of training data that is already there. So GPT instantly produces an impressive description focusing on sustainability, material and design according to the prompt. Now the question must be coming to your mind, how prompt means how quick it would be that it will convert every word into the embedding, then embedding would be the part of training data and the question will be generated. Yes, that is the beauty of the transformer, because many GPUs are working in parallel and they are so quick. So instead of looking at one sentence, everything is looked at a one full document. Second example of GPT is code generation and debugging. GPT models, specifically variants like Codex. So GPT variant hai, that is named as a Codex. It can understand programming language specific to the programming language. I can say write a code to generate a factorial of any number in Python. Right. Similarly, we can have the questions. A developer pastes an error message and broken Python scripts into a GPT. And what is this code not sorting alphabetically? Why this code is not some error? What is this error? How do I debug it? Anything related with the coding. It may be Python, it may be C or any other language. So the model identifies the misplaced function and provides the corrected data. So this is example of GPT. It's not example of BERT, because we are generating something, right? So we have to choose the appropriate model of the GPT. Let's take an example of Codex. Now the third model is Roberta. It is named as acronym as robustly. RO stands for robustly. Robustly optimized BERT approach. BERT comes from BERT and A for approach. And RO stands for robustly optimized. As we understand what we mean by optimized, If something is to be incurred, like expenses, those are to be minimized, right? We write our program such a way that it programs, or we do our task such a way that expenses should be lesser. While if something talks about the profit, we need the profit to be optimized, maximized, right? So this is how our programming code is to be optimized. So Roberta is nothing but it is an advanced NLP model developed by Facebook. So who did develop BERT, and then GPT, and then Roberta? So Google, OpenAI, and Facebook. So it is an improvement on Google's BERT model. It means earlier it was there by BERT only, by Google's BERT only, but the Facebook, nowadays it is Meta, they improved upon it, designed to better understand in the context of words in a sentence by training on a much larger data set. So it's a bigger data set. Why do we take big data set, bigger data set, or a huge data set, or massive data set? Because the more the data, more the features we can incorporate. So we can have the relationship between the words. If we have less number of data, we can miss the information. If we have more data, it means we can incorporate the context, concepts, and the relationship amongst the words. That is what it is needed in natural language. So using more efficient training techniques such as dynamic masking. So masking, just we have seen in the word, what we did, the next word that was predicted through the word, but it is already there in the training data set, and then it is checked. If the predicted one and actual one is same, it means we are going in the right direction. So dynamic masking is kind of a that we keep on. It's not fixed that every third word or every fourth word is masked. We can have first word is masked, then maybe 10th or maybe 11th as well, or maybe again 21st. It's a dynamic masking. So what is this model says? It acts as a fancy fill in the blank. If something is question marked, is masked, then again you fill it from the prediction. So reading surrounding text to grasp the deep nuanced meaning, new meaning, making it highly effective for text classification, question answering, and sentence similarity. Why do we do text classification? Example is kind of a spam or benign, right? Spam and non-spam. If some mail is one mail is sent to you, you would like to know it is good for me or not good for me, is right? Or question answering, we can have many questions, and those are to be answered such a way. It can be a one word, two word, short answer type, or a long answer type. Sentence similarity, if I write a sentence and I write another sentence, can I replace the second sentence with the first one? If they are similar, how similar they are, so that we can replace with each other. So in case of summarization, what we do, we take a big paragraph, big document, and that is to be condensed without losing the meaning of the big document. That is a summarization. Similarly, we use the sentence similarity. If this sentence that is smaller than that of the bigger one, or these two sentences are conveying the same meaning as of this one, then we can replace it with that. So what are the different examples of this, Roberta? Sentiment analysis, of course. The sentiment of a user is a positive, negative, or neutral. Roberta is a widely used to determine whether text is positive, negative, or neutral. That is sentiment analysis. So it excels at understanding context and nuance. It can handle subtle sarcasm. Sarcasm is a challenge with NLP. And similarly, we have a negation handling. If I say it is very good, it is not very good, it is not good. So all three sentences are conveying the different meaning. It is very good, it means it's a positive. It is not very good, it may be the neutral. And it is not good, it is a negative. So not is a negation handling. How do we how do we use this as a bigram model? Not and good together, not very good together, not excellent together. It makes something different than not unigram, not and good. The example is, say, if a company uses a fine-tuned Roberta model to analyze thousands of tweets mentioning their brand, right? So now instead of just looking for keywords like bad and good, Roberta understands that the tweet is like this, it is given like that. Their customer service is as useful as a broken toaster. So there's no word that saying is a negative, right? But one has to understand the semantics of that. What do you say? I ask participants, what do you say? What is this? What type of tweet it is? It is a negative, positive, or neutral? Please write in chat. The customer service is type of a brand, and we are asking our customers, and one customer is writing, the customer service is as useful, going like a positive sentence, as a broken toaster. What do you say? It is a positive, negative? Please write in chat. It is a positive, negative, or neutral? Please write in chat. Yes. Yes, Lakshita, you're right. Meenal, you're right. Why it is negative? Although there is no term not, but somehow it is a broken toaster which made it negative. So it is a heavily negative. It's not negative, it's a heavily negative, even without explicit harsh words. So harsh words may be bad, worst, not good. So somehow the sentence is not saying anything which is making it negative, but the broken and toaster is kind of a proverb which is making it negative. So that is what Roberta is considering. Now come to the topic, fine tuning in NLP model. Here we are going to use BERT, GPT and Roberta. So fine tuning takes this foundation and adjusts the model's parameters to specialize in a narrower task. So you try to understand, we have a big generic model and we want to make it a specific for a specific task, right? Suppose I'm using this deep learning model that is already there, say LLM, OpenAI ka LLM, large language model, Llama, right? And I can choose the model according to my capacity of handling it. So I don't want everything from that model. I want something specific to my purpose. It may be the sentiment analysis, maybe the question answering, or maybe the text classification, right? So I need to train it again. Yes, we have to train it again. So let's take an example, a BERT model that is a pre-trained on Wikipedia and books on the already available. Then I can fine tune on customer reviews to predict positive and negative sentiment according to my requirements. Suppose I own a company and I get the reviews or feedbacks from the customers. So I can ask BERT, I can tune BERT to handle my tweets, making it positive, negative. So they can have a label afterwards after every tweet. So it is kind of a existing language is there. We are tailoring it, we are tuning it to the new domain. That is, of course, somehow it is there in the generic one, but we are making it specific. Now the question is, how does it happen? So a technical process involves initializing the model with its pre-trained weights. Basically, what do we do when we make a model? We have an input layer, we have an output layer, and between there are hidden layers, right? And from input to hidden and hidden to hidden or hidden to output, we have some kind of a tuning with the weights and biases, right? Once it is done, when the model is tuned, when the model is found accurate, then we take the same weights. So during fine tuning, the models layers, especially those closer to the output, hidden layers kind of just before output and just next to that, are updated to minimize prediction errors on the task specific data. That is what we have seen in the feed forward. right? We go from input to output and we find if what is actual y and what is the predicted y. If there's a difference, then we go backward and tune it again. So we have got the learning rate, we have some hyperparameter tuning. The things are the number of epochs. So, for instance, in a classification task, the final layer of the model might be replaced with a new layer. Final layer means output layer with a new layer that maps the model's output to the desired number of classes. Suppose model is saying 0, 1, 2, but I want the result in positive, negative, or neutral, right? So that last layer may be tuned with the new one, that is may be considered as the output. So earlier the output again become the hidden, and it becomes new layer becomes the output. This is one way of doing it. Other ways of doing it that we can change the tuned parameters. Those are nothing but the weights and biases. So the learning rate is kind of a eta. If you remember it, eta is 0.001 or 0.001 or 0.1. So learning rate during fine tuning is typically smaller than during the pre-training to avoid overwriting the general language. So this is kind of a tip that when we do fine tuning, our learning rate should be smaller than that of the earlier ones. Now the question is, how do we get the earlier this one? That is given in the literature, or we can go and check the coding of that model which is trained already. So you must have heard the name Hugging Face transformers. These are available. So we have GitHub, we have Kaggle, we have Hugging Face, the resource libraries, and we can simplify this by providing APIs to load pre-trained models. So of course we have to write some interface between the source and the application, that is API, and modify their heads and train them on custom dataset. Custom dataset we have to provide at the time of tuning. So the custom according to the dataset which is needed for fine tuning is to be given to that, and somehow the weights and the model is for the generic dataset. So we have enough libraries, frameworks are there like PyTorch or TensorFlow. Those can be used. So in today's lab or hands-on session, these will be covered. Please be attentive and attend those sessions. So suppose I need to do something new. So how do I do it? So developers must balance retaining general knowledge and adapting it to the new task. So whatever has been learned, we should not forget it. And that same knowledge can be transferred to the new task. So a common strategy is to freeze earlier layers. So we have input layer, we have hidden layers, and somehow the output layer may be a bit changed. So which captures basic language features. Hidden layers will learn the basic things about. For example, we are talking about the sentiment analysis, we are talking about the text classification, more or less if we are using a Hindi language or we are using English language. So more or less features have been extracted, and we can have the prototype or grammar of a language, like in English we have subject, verb and object. So some kind of relationship, parsers and stemming, lemmatization, everything has been used. So let's take an example. When adapting GPT-2 as a version of GPT for a medical chatbot, the initial transformer layers might remain fixed to preserve grammar and syntax. That is what I was telling you, because it depends on the language. So grammar and syntax have been preserved by the layers of transformer, while the final layers are trained on a medical dialogue data. So kind of a question answering. Medical dialogue data, it means kind of a question answering, and we can have a different vocabulary in terms of medical domain that may not be understood by a generic generic of that language, let's say English. So as we have already discussed in the second class, what do you mean by overfitting and underfitting? So Overfitting is a risk, especially with a small data set. It means training is not yet done properly, overfitting. Or it is trained such a way that it understands only the concepts given in that small data set. It doesn't understand beyond that. So techniques like dropout, early stopping, and data augmentation are often applied. What we mean by dropouts is kind of a batch processing. In a batch, if we have said 100 features, right, those are part of input. So everything is not being used properly, we can leave something. Those are not needed. Early stopping, it means we can stop in between when Suraj, early stopping, it means our work is done and we don't have to go by that number of epochs, right? That is early stopping. Data augmentation is something to be added. हाथ लगा दो बस, इधर नहीं, इधर से हिला दो इसको, हिला दो, हिला दो. मेरे से वहीं से उस पे नहीं जा पा रहे हो क्या? So fine tuning is doesn't happen in one go. Whatever we have in terms of generic data set, it is to be done, it is to be fine tuned in many iterations. It means if we go in one epoch, if results are not good, then we go back to the initial things, tune something new, and come back, and then keep doing until unless we are happy. So these are the batch sizes, epochs, those are part of the hyperparameters. And layer configuration to optimize performance, right? So we have got parameters and hyperparameter tuning. Hyperparameters means batch sizes, epochs, and number of layers. While in terms of parameters, kind of weights and biases. So this approach saves time and computational resources compared to training from scratch while achieving strong results for specialized applications. सेंटर में कर दो उसको. कितनी देर में इसको वापस करना है? बंद हो गया था अपने आप. हिलाना पड़ेगा, क्या करना पड़ेगा उसको बता. Now, what are the steps by which we do the fine tuning? So first of all, we need to select the base model. Which model it is best suited for, that we have to compare. So again, we have to compare the best model according to the task, that is the objective, and the budget. It means every pre-trained model may not fit for our budget. Budget, it means cost. Cost in terms of the number of GPUs, number of the memory, the size of the data. It takes how much size it can take. So choose fine tuning method. First, we have to choose a model. Then which fine tuning model is good. So there are certain good fine tune models is fine tuning, supervised fine tuning, and PEFT, LoRa, and CLORA, etc. based on the task and data set. I'll take these all one by one. Then we have to prepare the data set, structure our data set for a specific task. For example, I need to do the sentiment analysis. So my the input will be a sentence or maybe a paragraph, and then y will be my 3 discrete values, not negative, positive, and neutral. And it may be spam or non-spam, or it may be anything. So it should suit to my objective. Then training, we need to train it again on the same model which we have chosen on as a base model. So again, we can use the TensorFlow, PyTorch, or high-level libraries like transformers to fine-tune the model. So evaluate and iterate. Those who are the students, MTech students, they may do it they may practice it. And in today's session, we will be doing it to showcase you. So once everything is done, we have to evaluate it. And we have to check the accuracy. If it's as per the satisfaction, then it's okay. Otherwise, we have to retrain, or we have to choose the different model. So all the steps are to be repeated. That's why it doesn't happen in one go. We have to take many iterations sometimes. So what are these fine-tune methods? Let's take one by one. So these are basically supervised fine-tune, instruction fine-tune, PEFT, performance-based fine-tuning, RLHF is about the reinforcement learning, human in loop. So let's take first one is a supervised tuning. It further trains a predefined model on a specific labeled dataset. So it, as the name says, supervised tuning. So it means we are taking the classification type of objectives. So we need to update all model weights to adapt it to the new task. New task is, for example, this is classification or a sentiment analysis or any that is a supervised. So base for tasks like sentiment analysis and text classification where label data is available. So that data, look at this second one. We have to choose the base model. Then which model? Here we have chosen the supervised fine tuning. Then the data set should be labeled because it's a supervised. As the name says, supervised, it means we can take only the classification objectives. Now the training and then evaluate. So here the best for task classification thing. Then we can include training LLMs on chat data like question answering, email classification, code generation, medical document summarization, but kind of a supervised. It means we should have the data which is supervised already. The use case may be the different, but the data must be of supervised learning. The second thing is a second type of fine tuning is instruction fine tuning. It means kind of a prompt. We are adding on it. So we need to train the model using datasets pairing instruction. The dataset earlier in the supervised fine tuning, there were data X and Y. X is input, Y is label already. Here we have a dataset which is having the instructions and what is expected outcome, right? That's more or less like a X and Y both. So it helps the model generalize to new task and follow natural language instruction. So every word of that instruction is converted into the word embedding, and then word embedding becomes a part of training and it works. Let's take an example. If we have the translation task, like instruction is nothing but a prompt. So I'm asking my bot or my model that translate bonjour from French to English. So what is expected? Response is hello, right? So I'll provide such kind of data to my base model, like this is my instruction and this is answer. This is my instruction, this is answer, this is my instruction, this is my. So it makes a data set. So we have to train this data set on my base data set model. The new data set is for this purpose. So the different kind of data set may be summarization task. The instruction is summarize the main arguments of the articles in 3 bullet points. So my data set should consist of the input and the response, input and the response. And the data may not be too less, should be moderate enough so that we can use the existing model with the new data set. The third kind of thing is a parameter efficient PEFT, fine tuning. FT stands for fine tuning and P stands for parameter efficient. It adjusts only a small subset of parameters. There may be several parameters in the base data model, but we are just changing only certain parameters. Otherwise, we are keeping the remaining parameters same, right? So PEFT includes the training adapter like low rank reparameterization. It is known as a LoRa. In short, in say LoRa. Low rank. LO stands for low, R stands for rank, and it is parameterization. It is or just prompt tokens. So it enables efficient adoption of large models, जो कि पहले से base है हमारा, with less memory, क्योंकि already train हो चुका है, so we don't need much memory, and computation. For example, PEFT can reduce trainable parameters. How many parameters are trainable? As we keep on increasing our input, and we have a big hidden layer, a number of nodes are much in this one, so we'll be having lots of trainable parameters, right? From tens of thousands to 10,000s or millions, right? To just a few thousand. So we can have the big number of parameters to just having few thousands only. That is what it is, low rank. So in the base model, there are too many parameters, but in this fine tuning, we are having only less number of parameters. That is known as a low rank. In the PEFT, we have LoRa. It fine-tunes models like Llama. People are using it. It is very popular. There are various versions of Llama. Nowadays, it's, I think, 30 billion or 300 billion. 7 billion on a single GPU by training small added metrics rather than the full model. Instead of using the full model, we can take part of that and tune according to the need. That is tuning of the parameters, tunable parameters. The higher version of LoRa is a CLoRa. It means quantized LoRa. Quantized. It means whatever has been done with the LoRa can be again refined. So it further reduces the memory by quantizing the base model to 4-bit or chota model ho gaya. For example, if we have a 65 billion model to be trained on one GPU, so we can just reduce it by 4th. And the other one is a stable diffusion dream booth is the name of the model. It uses again PEFT to teach new concepts, that is specific person or object, to a model without retraining it. This is the first model. It doesn't need a retraining. So far we are saying we have to retrain on a specific data set, but here there is no need of. So again, we have some frameworks available for that and the data set available. So just all the students would like to do it as their project or their assignments. Now the question is, what is the core problem with that? Why it is not that successful? Of course, everything has some advantage, may have some challenges. So the core problem is the memory constraints. It means memory is nothing but the cost. So everyone is not having that kind of memory. So traditionally, to train a neural network, we must hold the model's weights, right? We are worrying about the weights and biases and gradients and optimize the states in GPU's memory. Everything is kept in a virtual RAM. RAM, we need a big RAM to keep all these weights, gradients, optimizers, states. So 65B model of Llama is in 16-bit. Requires, if this model is used, so how much we need? We need 130 GB plus VRAM. VRAM is keeping the weights, gradients, optimizers just for weights. इतना बड़ा हमें चाहिए ही चाहिए. So full training needs over 780 GB of VRAM for weights, gradients, and optimizers. So limitation is high-end consumers like GPU and RTX 3090, 4090 has only 24 GB. इतने बड़े अच्छे वाले जो हैं, they have only 24 GB and we need 780 GB. So difficult to manage. So what is the solution? We can take the GPUs on rent from the cloud, the subscription based or maybe rental basis. Solution is CLORA. CLORA is a quantized LoRa. So here instead of 16-bit, if we can do it on a 4-bit, so CLORA breaks this bottleneck by doing two things simultaneously. First is 4-bit quantization, the storage part. Instead of storing the 650 billion parameters in 16-bit or 32-bit, CLORA shrinks the base model to 4-bit. It means base model is to be compressed only on the 4-bit model, and then you do whatever you want to do for a new task or a specific task, that is fine tuning. So CLORA, of course, it has again some challenges. It may lose the accuracy. It may lose some information. So what is the maths behind it doing from 16-bit to 4 bits? So as we have 16-bit size, it means we have 65B model that takes 130 GB in 16-bit and now takes only 35 to 40 GB. So divided by 4, including the overhead that fits on a single high-end GPUs. So key innovation is CLORA uses NF4, 4-bit normal float, a data type optimized for neural network weights, which are normally distributed. I hope you are getting it. If you have any question, please let me know. The LoRa, the training is done on the LoRa, that is 16-bit. So quantized weights are frozen. Quantized means the compressed one is read only. To train, attach tiny learnable 16-bit adapters. From LoRa to CLORA, what we have done, we have made our weights, those are frozen. Those cannot be changed, read only. We only calculate gradients for those small adapters, not the 4-bit base models. So this makes the training memory footprint tiny. So smaller. This is nothing but smaller. So for some specific case, CLORA works well. The fourth type of fine tuning is reinforcement. As you know, it's a reinforcement learning. We have supervised learning, we have unsupervised learning, and the next one is a reinforcement learning. In the case of supervised learning, there is always supervisor with us in terms of why. In the training data, we have the label, while in unsupervised learning, we don't have the label. While in reinforcement learning, the labels are given in terms of the reward or punishment immediately. If you take some event happens, and if it is going great, then some award is given. That is nothing but a supervised. And if something goes wrong, it means it's a penalty. So from that only, from that instances, we have two labels, and it keeps on doing. And from there, the machine or model learns. So it uses human rating to teach a model to align outputs with human preferences. It's good or not good. It's an award or a penalty. So it involves 3 steps: generate outputs, train a reward model from human feedback. It means human in the loop. Here we have human in the loop. And optimize model behavior like reinforcement learning. And it is ideal for tasks requiring alignment with human values. Whenever we can afford the human intervention, then this reinforcement human feedback is applicable. So we have seen some examples. Let's take kind of a question for you. So sentiment analysis fine tuning is there. What is the goal? Adopt a general LLM to classify sentiment. We have to take the general LLM. Now we can tune it on the basis of movie reviews. So we have movie reviews dataset, that is X and Y. X is our text and label is Y. It is already there with us. Then we'll tune it. The generic model will be tuned as per the new dataset given. So first start with the pre-trained LLM, generic one. Provide labeled sentiment dataset, that is for the new task. Train the model, we have to train it. We have to accept that we have to train it again. Now with this dataset, it means all the parameters, those are tuned already, will be used here. So model learns to predict sentiments more accurately. Let's take an example. If we have the phone battery lasts all day, I love it. It is nothing negative, it's a positive. The movie was amazing and inspiring, it's a positive. The product stopped working in 2 days, although there's nothing negative word. It's not worse, it is harsh, no harsh comment. It's a product stopped working in 2 days. So somehow context is revealed and said it is a negative statement. It was okay, nothing special, nothing bad. If it is sentence like this, it was okay, nothing bad. It is again a neutral. Nothing positive, nothing negative. So again, question answering kind of example of fine tuning. So again, look at this. Customer queries your X and response is your Y. So our data set the new data set must have this kind of data. So all the instances having the query and the response. So training is done and then inference is used. So after fine tuning, the chatbot can answer questions related to the company's policies. So now the question coming to your mind, are they such kind of data is not available in the generic? There may be some data, but we want something specific to our company. So they may have something different that is there, we have to train it, right? So every private things, we can tune it. We can use the generic model that is available to us, and we can use it for our purpose, our specific purpose. So again, the next example, medical text classification. Adopt an LLM to medical terminology. It may not have the generic things. So we have to provide the medical terminology, right? In terms of X and Y, X is your parameter and Y is the answer to that. So here the text is X, that is patient reports chest pain and shortness of breathing. What is the disease or ailment to that patient? So label is given, it is pertaining to cardiology, right? So similarly, we will have data set available to text and label, text and label, text and label. So many texts with the labels. So with this data set, we'll tune the generic model. So fine tuning helps the model understand domain specific vocabulary. So that may not be available in the generic data set. We have to train it on a specific vocabulary, that is medical. Similarly, we can have other domains, those may not be understood by a general people, that is not available in the generic data set or a generic model. Similarly, we can have the example of code generation. For example, I ask fine tuning an LLM on Python repositories, so it generates better code, right? And the input is write a Python function to calculate factorial. It means we must have the data set with input and output, input and output, input and output. It means we are asking our model to learn the Python. Here, the input is write a Python function to calculate factorial. So we keep on doing such kind of prompts with the answer. So what will happen? The generic model, which has been trained already, will be trained or tuned with this kind of data set. So we'll have lots of inputs with the outputs. Now is the time for the question. We'll do some question and later we'll come to the next topic. So I'll request everyone to please write in chat. Please write in chat if you understood. If you have understood. So fine tuning is mainly used to, options are train a model from scratch. Is it? Okay, not sure. Adopt a pre-trained model to a specific task. Is it? Increase model size. is a bad answer, bad option, because we don't increase. Remove training data. No, it's not like that. So answer is correct. B. Adopt a pre-trained model. Adopt a pre-trained model to a specific task. It's very clear. All other options are not correct. Train a model from scratch. No, it's not a fine-tuning. Increase model size. No, nothing to do with the fine-tuning. Remove training data. No, it's not possible. So correct answer is B. Thank you for all who answered it. Ready for the next question? Please be ready for the next question. So which data set is suitable for sorry for interruption. So which data set is suitable for fine-tuning a sentiment model? So options are random unlabeled text. No, random unlabeled is not possible. Numerical data set, images of objects, labeled positive and negative reviews. So we want some input and what is the sentiment of that input. So X and Y. X is your input sentence and the answer in terms of Y. That is a review, negative, positive. So correct answer is D. You are right. So ready for the next question? So fine tuning helps LLM learn task specific knowledge, hardware configuration, network protocols. Fine tuning helps LLM learn task specific knowledge. This is the correct answer because this is the objective of fine tuning. So we have generic model in hand. We have to make it specific, but we have to provide the specific data set and train it again on the same model. That is how it goes. Correct? So answer A is correct. Now ready for the next question? What we have learned so far, these are the questions pertaining to those understanding. Which is a common challenge in fine tuning. Everything is not perfect. We have some challenges to overcome. So what is the challenge with the fine tuning? It is something related with the internet? No, nothing. Poor quality training data, which is common challenge in fine tuning. Too many CPUs or GPUs, large keyboard size, all are incorrect except poor quality training data. If we don't have the good quality training data, then it may not lead to the accurate answers. Now, next question. Please answer it. Fine tuning is performed after data collection, pre-training, testing, and deployment. So it means we have generic data set already in hand that has been trained, and we have to tune it according to the specific task. So you are right. Everyone is right. Answer is pre-training. So the pre-training is done or training is done on the new data set that is specific to the task. Now, next question, please. I request everyone to please answer the questions. If you don't understand how this is coming, please let me know. I'll explain. You can write in chat how is coming. If you have any doubt, please let me know. I'm here to solve the answers, give you the correct answer. So in fine tuning, the model weights. Priyanka Gupta is saying B. The fine tuning, the model weights are completely deleted. Model weights, no. Randomly generated again, no. Slightly adjusted using task specific data set, not changed. So correct answer is we tuned according to need. We may not take as it is. We can tune the weights also according to the need. Answer is C. Slightly adjusted or may not be adjusted. We can keep as it is if needed. So this is the fine-tuning large language model using dialogue-sum database. Today we'll be doing this thing. Or otherwise, these are available on the slides. These are available on the slides. So everything I have written here, how do we install the datasets, how do we install using the pip, install transformer, evaluate, accelerate, transformers like torch, and pip install PAFT we have learned. Parameter efficient fine tuning. So this is, I'm skipping for right now. We'll come back to that in the afternoon, evening session. So that is 10 steps are enough to have the, to do the fine tune depending on the specific task. So we must have the data set for that. Now let's come to the AI agent and agentic AI. AI agent and agentic AI. So you must have heard the name generative AI, AI agent, and genetic AI. So far we have seen what is generative AI. It means it generates the new thing. It creates the videos, it creates the images, it creates the text, and everything it is, the new thing is being created with the generative AI. We have two new terms. These are AI agents and agentic AI. And then we'll connect the dots with all these three technologies. Let's take one by one. So first of all, what is agentic AI? And the question is for you, that if we have many agentic AIs, can we talk to each other? Agentic AIs are automatic doers, autonomous doers. Can they do talk with each other? Answer is yes. Yes. So these are agentic AIs are autonomous doers. So agentic AI is nothing but an architecture. Is again a model or approach where an AI agent, it's a new terminology, AI agent, can autonomously plan, reason, and use tools to complete complex multi-step goals with minimal human intervention. So far, we have seen that human in loop is always there. When we talk about the data set, it should be unbiased. It means we should keep an eye on that. If we have an imbalanced data, there are two classes, right? And we have a 90% data from one class and 10% data from the other class. This is the imbalanced data. And of course, results will be inaccurate, right? So everything is to be watched upon. So always in all the steps, human in the loop is there. Got it? So here again, we have human in the loop, but we want the minimal intervention. We want, I'll ask that Siri, Alexa, what I do? I ask, please do it for me, please do it for me, please do it. But they have their own limitations. Everything cannot be done by them. These are the virtual assistants. What if I have many virtual assistants in my hand and I ask them to talk to each other and do it for me? You are the expert in this, you are the expert in this, you do this for me, you do this for me, and please communicate each other and give me the results. Got it? This is what we want actually. And if they are so trustworthy, I can start believing on it. I'll not question. So example like agentic AI is nothing but a smart email assistant. Suppose my email inbox is full of emails. First, I have to check what are the good for me, what are to be taken today, and what are not to be taken today, or maybe referred for tomorrow's box. I can just say unread. I'll see it tomorrow. Right? Everything I can leave on agentic AI. If I can leave it on agentic AI, if it is good, it is a prompt, it is very important, answer it quickly. So on my behalf, if they can respond in such a way that it's like me only, right? That is agentic AI. So an assistant that actually manages your email, that is my agentic AI. So the days are coming where everything will be done by these AI's agents. So again, I can refer agentic AIs, AI systems that can autonomously take actions to achieve a specific goal. Right. These systems are perceive their environment, what are the external factors, make decisions. They take their own decision. They don't have to depend on my voice. They don't wait for my decision. Just take the decision. That's why we need it. No? Suppose uh, in mid of the night, I got an email, right? And something to be answered quickly. Looking at my data, those are lying in my computer or desktop. They will quickly get the data from my desktop and answer it without letting me know. And the decision is right decision, of course. And perform actions, sending reply back to emails, that is the performing actions, and learn from the feedback. Something out of 100 emails, one is going wrong, one is not correct as per my satisfaction, then we can ask them to do it again, correct it. That is learning from the feedback. So what are the key characteristics of agentic AI? Is autonomy, operates without constant human control. I don't want to control it, being a human, and I given rights to you that you do it, authority to you, you do it. Goal-oriented behavior works to achieve specific objects. There may be certain objectives. I can say that this is the job, this is your job, this is your job, this is your job, and remaining are for my purpose. I'll do it later. You do only 3, you do only 4. That is goal-oriented behavior. Decision making chooses action based on the information. If something, I get a mail that you have a meeting tomorrow, then the agentic AI will set my calendar, right? And something that the calendar is already marked at that time, right? The date is booked already, then it may answer it again back or reply the email. That is not possible. Adaptability adjusts behavior based on the feedback. So it's not like that once agentic AI started doing this, that will remain forever. It can change uh, the behavior or feedback based on the feedback. So they are the autonomous doers. Not only so far, not only reading the email, answering the email, or answering the email wisely, right? So email writing is okay. I understood it. It's not like that. It's like that. The calendar, the date is already booked, and you can adjust that date. Even the agentic AI can suggest the good dates on my behalf. So an agentic AI agent is a system that can perceive its environment, make decision, and take action to achieve a specific defined goal. The simple AI agent is not agentic AI, it's an AI agent. The spell checker, that is what we are using it so many years. Spell checker, Turnitin, these are the AI agents. Think of the red underline in your Word document. And sometimes we start writing and we get some recommendation. You type this word, you do it like that. That is kind of an AI agent. Now, everything is not perfect. Again, we have some challenges or limitation. It is passive. It's not active. It can find the mistakes, but it cannot decide to fix it for you. We have to take a call. That is the AI agent. So, nor can it understand the context that hello was meant to be hello. For example, somehow some out of vocabulary word is there for the AI agent, but being a human being or a intelligent person, we understand it. But AI agent may not take a call upon that word. Let's take an example. HEHLELO. It is meant for hello, but it is because AI agent is passive, it may not understand it. It's just an example. There may be several. So key limitation is it is passive. It cannot find the mistake, and it cannot take the call. So AI agent is nothing but an entity that observes its environment, processes the information, take action to achieve goal. Sometimes, for example, a self-driving car detecting obstacles and choosing a safe route. There may be several options, which is the best. It can be chosen by them. The components of an AI agent is sensors, two external sensors, that is environment. Decision planning and module determines the best action, and actuators execute action in the environment. So sensors allow agents to perceive the environment like cameras, microphones, GPS. These are the sensors. Temperature, in terms of agriculture, we can have soil sensors, we can have other weather sensors, humidity, so many things. So in software agents, sensors may include text input or system data. So not only the hardware sensor, we can have software sensors also, software agents, that is text input. What are the keywords in natural language? Maybe the input. Actuators, second part, actuators perform action based on the decision. There may be some hardware things like robot arms, vehicle steering systems, software commands like execute this, delete this, update this, automated responses in chatbots. These are the actuators. Then AI agents continuously interact with the environment. It's not that once it is taken environment, it is same, it remains same. After regular intervals, it keeps on taking the new things or perceive the new things. So this loop improves agent performance. So planning helps an agent determine the sequence of actions required to achieve a goal. For example, navigation system planning the shortest path to a destination. So you must have seen in the GPS, the maps, the routers. What happens if you take the wrong path? Then it say reroute it. It reroutes it. That is the shortest path afterwards. If you're taken the wrong one or something goes wrong. So how does it happen? Agents improve performance through learning methods. So reinforcement learning is there, machine learning, experience-based adaptation. So this helps agents make better decisions over time. And it keeps on storing the decisions taken. And kind of it becomes the training data for them. Right? If something is being done again and again, then it becomes the part of training data. So it's not training is not once, it keeps on doing. Now there's a term that is a multi-agent system. It involves multiple AI agents. So one agent may be expert in doing this, for example, cooking. Second is good in teaching. Third is good in researcher, and all are interacting with each other. So agents may cooperate with each other. They may compete with each other, but of course share information with each other. So though it's not like that one is doing wrong, then second. Example, multiple delivery robots coordinating tasks. We have multiple robots, kind of AI agents, and if someone is becoming the obstacle for other, the first one will wait for that to go, or it may ask that wait, I am going first, kind of a coordination. Now, what are agentic AI? Agentic AI is widely used in robotics, autonomous vehicles, intelligent virtual assistants, smart home systems, automated customer support. Now, I'll connect all these three: agentic AI, AI agents, and agentic generative AI. So, if I say input, plan a 3-day trip to Delhi. Of course, this input or prompt will be sent to LLM. and it will be done. Here is your 3-day itinerary to Delhi, Pune, or Maharashtra, whatever. So it is easy. LLM can be GPT-4, Claude, Gemini, whatever you want to choose it. So in general, we say it's LLM. The case 2 is Indigo flight prices for tomorrow from Delhi to Jaipur. The user wants to know the flight prices from Delhi to Jaipur. That is for tomorrow. Then the output is I don't know the latest price. My knowledge is cut till September 2025. That is a training. Last training kab hui thi. So in case 1, output is based on pre-trained done on LLM. That is a normal LLM, normal question answering. In case 2, LLM will not be able to tell because its knowledge cutoff date is September. In case 2, so this is generative AI. This is an example. These two are the examples of generative AI. In the first case is okay. In the second case, because the training date was before that, it's not yet trained on today, it may not answer. It is an example. There may be several cases where it may answer, I don't know. Right. Now, what happens in case 3 also in generative AI? Input is Indigo flight prices from tomorrow from Delhi to Jaipur. Right. Indigo flight prices for tomorrow from Delhi to Jaipur. And it is a kind of prediction. It's not exact, it's kind of a prediction on the basis of the past data. So LLM with pre-trained knowledge and tools can give us the latest information as well. And this may be the machine learning kind of thing, prediction, as well as the LLM may have some interaction with the APIs. APIs are several, that is external knowledge. And the API Expedia, which is providing after training data. Here in the case 2, it is saying September 2025, after September 2025, I don't have the data about this. But for immediate reference, which is having the till date knowledge or information, we may call the API. And this is how it is answering the prices from 2000 to 5000. It's not correct, but it is this. So Expedia is what? It is a travel API, which is helping LLM. So from the external sources, we are getting this information. It's a RAG. Now, second is AI agent. First, we have seen generative AI. Now I'm comparing with the AI agent. So AI agent question is same. Book me the cheapest flight. Book me. It's not asking only, booking also. Book me the cheapest flight from Delhi to Jaipur tomorrow. We want some action to be taken. So what LLM will do? Of course, API is also there to have the current information, today's information. First, it needs to search the flights because it's asking cheapest flight. Searches all the flights and then it has to mark the cheapest one. Decide the cheapest one and then books it. Booking is the kind of action. So this is an AI agent which performs the actual task. So this is autonomous but narrow, task specific and doesn't span multiple or evolving goals. It is simple to do. It's not complicated, right? So that is a case of AI agent. Now, input is book me a flight from Bangalore to Jaipur for my 7-day trip. I'm making it a bit complicated. The weather should be sunny all the days. The flight budget should be less than 15,000. So many constraints. So it has to call the many APIs because not only the cheapest flight we need a weather of 7 days. So we call another API AccuWeather. So two APIs are working and both are communicating with the LLM. So first it checks whether to find 7 days in December because it's asking in December where it is sunny. Weather is to be checked. Compare airlines is a role of second agent, AI agent. Find a flight with budget. Again, it's not cheapest within the budget. It means it may be more than one. without layover, it means zero stop. Then book it, give suggestion for a hotel and taxis. So output flight booked for rupees 12,760 from 10th of December to this. Weather is sunny all the days. I found a few good hotels. Do you want to book it? This is the role of AI agents. So here we have got two AI agents. Now comes agentic AI. So now look at the question. Book me a flight from California to Jaipur for my 7-day trip in December. The weather should be sunny all day. Find budget should be less than 50,000. So here we have has more than one AI agent, multi-step reasoning, multi-step planning, works on complex goals autonomously. So flight booking AI agent, depending on that. And then we have something to be checked because it's about the international travel. International travel is a US residence. The question was from the US resident. So he is willing to come to Jaipur, but does he have the passport, a valid passport? That is not even provided explicitly, but implicitly, this is the role of the AI agent. The passport validity is to be checked. So the AI agent is saying, it looks like your visa has expired or your passport is to be renewed, right? So it means it has some data from that US resident. You need to have a valid visa before you travel. That is a kind of recommendation, advisory, or a warning. So this agentic AI will check whether the visa is available or not. It's a immigration AI agent. So we have flight booking AI agent, which is checking the weather and checking the fare. And the second AI agent is a immigration AI agent. That is agentic AI. Now it's time for the question. Whatever we have done, please have a look if you're ready to answer it. Agentic AI refers to AI systems. Yes, Priyanka, it is B. That only stores data? No, it's not the role of the AI systems. Act autonomously to achieve goals. Only perform calculations? No. Only translate languages? No. It is more than that. So it is, of course, using the data and some comparisons it may do, maybe some translation also. But anyhow, it acts autonomously to achieve the goals. What is an AI agent typically interacts with its compiler? Nothing to do. Database? Nothing to do. Keyboard? Nothing to do. Environment? Yes. Keeps on checking the environment. Environment is to be updated regularly. Answer is D. Next question. Which of the following is a key characteristics of agentic AI? Autonomy. Which of the following is a key characteristics of agentic AI? Yes, correct. It is autonomy. It doesn't have the manual control. That is what we want to remove the human in the loop. We want a minimal intervention. Static behavior, no, it keeps on changing. Limited learning, no, it keeps on learning. So all the answers apart from an autonomy are wrong, not correct. The next question is the component that performs actions in environment. We have seen the environment, external data. Sensors, component that performs actions in action लेना है. सेंसर से तो हम डेटा लेते हैं. Actuators are the actual performers. Tokenizer, encoder, no. Answer is actuators. Correct. Next question. The process of selecting actions to achieve a goal is called? Planning is the correct answer. First, it has to plan what is the goal. It may be sub goals. There may be sub goals, right? Sub goals may be in parallel or serial. So if they are in serial, then they can, multi agents can do it. So answer is A, planning. So we can take a quick break. Now we can compare. I'll come back to this slide later in the second one after prompt engineering. So we have seen the fine tuning here. So today we'll be covering prompt engineering also, and then prompt tuning. Then we'll compare all these things. The question must be coming to your mind, how prompt engineering is different from fine tuning. So this is the end of this session. I'll come back after some time, after a break of 10 minutes. Please come back immediately. Then we'll do prompt engineering, prompt tuning, and we'll try to understand how it is different from the fine tuning.